All right, so for section 1.7, this is called the distributive property. In your favorite video game, you rotate shapes as they fall to make them fit together in a rectangle. When you complete an entire row, you score 1 point for each square in that row. The screen at the right shows your latest game in pause mode. Using only the shape shown, what is the maximum possible score for this game? Explain your answer. So, I know you can't see the picture really well, but the maximum score is when you have one square in each row. So this is very similar to Tetris. So look at how many squares you can fit in that row and make sure it's evenly distributed, hence the distributive property. All right, so as you see through your notes, examples of the distributive property. So I'll have to show you the textbook page. All right, so the distributive property is also known as the rainbow property. So it will be, the rainbow property will come more into play when you actually see problem 1. So 3 times the quantity of x plus 8. So 3 is being multiplied to this quantity 3 to x plus 8. So distribute 3 to both x and 8, hence the rainbow. You see the rainbow. So 3 times x is just 3x, 3 times 8 plus 3 times 8. So therefore, 3 times x is 3x, and 3 times 8 is 24. So therefore, this is your answer. We multiply 3 times x and 3 times 8 to get 3x plus 24. So we look at letter B. Now this is written a little bit differently. So it's the quantity of 5b minus 4 times negative 7. So to rewrite this to make it a little bit better, I'm going to rewrite it like this. And what property am I using? The commutative property. So negative 7, so I'm going to distribute negative 7 to 5b, and I'm going to distribute negative 7 to negative 4. So negative 7 times 5b, and I'm just going to use plus to be on the safe side, negative 7 times negative 4. So negative 7 times 5b. Remember, we could use the associative property to switch the parentheses around. Plus negative 7 times negative 4. So we're left with negative 35b. Remember, because that's a negative times a positive. Plus, and what is a negative times a negative? A positive. So negative 7 times negative 4 is 28. So this is negative 35b plus 28. So remember, we use the rainbow property, the distributive property, to distribute negative 7 to both terms. So why don't you try 5 times the quantity of x plus 7 and the quantity of 2y minus 1 times negative y. All right, problem 2a. Now, we want to know the sum or difference is equivalent to 7x plus 2 divided by 5. Now, this is where I call this the butterfly property, where if there's one number in the denominator, only one term in the denominator, you can split it up like this. So you have 7x over 5 plus 2 over 5. So you literally split it up. It only works if there's only one term in the denominator. So why don't you try letter A, 4x minus 16 divided by 3, and also try 15 plus 6x divided by 2. All right. So, problem 3, we want to know what is a simplified form of negative of the opposite of 2y minus 3x. Now, as you saw in problem 1, you see that there is a visible number, 3. But now, this just has a negative number. If there's nothing in front of the parentheses, you assume it's 1. So we can rewrite that as negative 1 times the quantity of 2y minus 3x. So now we can use the distributive property. Negative 1 times 2y and negative 1 times negative 3x. So negative 1 times 2y plus negative 1 times negative 3x. So remember, this is a negative times a positive. So negative 1 times 2y is negative 2y plus negative 1 times negative 3x is positive 3x. So that's your answer, negative 2y plus 3x. So why don't you try, I didn't tell you what got it to try. why don't you try letters A and C of the Got It in your student companion book. All right, we're going to skip over problem 4, and we are going to go into problem 5. We'll go over the words, term, constant, coefficient, and like terms tomorrow. All right, so I want the simplified form of each expression. Now, you can see that each of these terms both have an x squared. So, therefore, we can combine these like terms. Like terms have the same variable factors. So, we're going to ignore these x squares for right now. 8 plus 2 is 10. And then I'm going to put on the x squared. So 8x squared plus 2x squared is 10x squared. Think about it as apples. If you have 8 apples and you add another 2 apples, you're going to have 10 apples. All right, so letter B gets a little bit trickier. We want to simplify 5x minus 3 minus 3x plus 6y plus 4. So what I like to do is I like to circle what I have in common. So I have a 5x here. Do I see any other x's? Yes, a negative 3x right here. All right, so do I see constants, numbers without variables, just numbers by themselves? I have a negative 3 and a 4. All right, so now I'm left with y's. Do I have any y's? No, just y by itself. All right, so let's combine 5x minus 3x first. I have a 5x minus 3x, which gives me 2x. All right, so now let's do my constants. I have negative 3y plus 4. Now remember, I can rewrite this as 4 minus 3, which is 1. And then I'm just left with a 6y. So now, what I can do is I can combine everything. My answer is going to be 2x plus 1 plus 6y. And the reason I'm adding all these together is because this is positive, and this is positive. So that's my final answer. So, because those were the only 2 examples, why don't you try letters A and B?